Hi, good morning. Thanks for joining today's vExpert briefing from Dell EMC and Big Switch, focused on the ideal SDN fabric for VMware's software-defined data center. My name is Greg Holzrichter, and I'm the Chief Marketing Officer here at Big Switch, a VMware veteran for close to 5 years back in 2005, so I'm really excited to take the vExpert community through what I hope is a really interesting conversation that's relevant to your areas of expertise. Our panelists today are Prashant Gandhi, Big Switch's Chief Product Officer, Gary Greenberg, Senior Principal Consulting Architect from the Cloud Software Solutions Group in Dell EMC, and Ram Haridasa, Networking Solutions Architect from Dell EMC. So we would love to have your technical questions as you go through the presentation, and you can actually do that by engaging with the chat box with this platform. And we also encourage you to go through and ask questions on bigswitch.com/webinars. So without further ado, we'll go through the brief overview of the agenda and then get started. We want to talk through the key software-defined data center requirements and pain points. Gary will be taking us through that section. We'll provide an overview of a unified architecture and integration points. We'll then switch over to discuss some of the trends in open networking and why that's relevant to the vExpert community. We'll have an interactive poll and get some feedback from the group. And then we'll go into what I hope is quite interesting overview of the Big Cloud Fabric solution, how we integrate with VMware through an API, through vCenter, support for NSX, as well as some working demos, which I hope you'll find pertinent and interesting. So without further ado, I'll go ahead and pass it over. And why don't we go ahead and get started. So from a networking perspective, I'll hand it over to Ram.
Thank you, Greg. Good morning, good afternoon, everyone. I want to get started with our discussion today by just looking at the evolution in the IT space, information technology space, and where we were and where we are today. Just to give you, and this kind of covers a couple of decades, so just to give you a perspective, or at least the perspective from Dell EMC's point of view, is the platform, the IT platforms have evolved essentially from mainframe computing back during the days of IBM and mainframes, essentially where the intelligence was in the mainframe computers with proprietary networking and proprietary protocols and SNA and things like that from quite some time ago. That kind of evolved into the next generation, if you will, of server-based computing, so client-server models. Again, these models, I guess, were a tremendous improvement from before, but they were typically characterized by proprietary architectures, a large number of protocols, evolution, basically the evolution of the internet, and proprietary both in terms of the networking operating systems and also the hardware, the ASICs, if you will. This kind of leads us to where we are today, which is the what we call the cloud computing or platform, the third generation of this platform. So what does cloud computing basically, what does that mean, or at least what does it mean to us in Dell EMC? So we look at this as essentially, the mobile computing phase, if you will. Basically, any connectivity anywhere on any device and being able to access any application that you would like to use. So what this essentially entails is for solutions to have, the ability to use standard orchestration tools and automation tools, being able to support, overlay controllers that are, optional controllers depending on what the architecture is, but essentially a variety of networking operating systems and being able to use merchant silicon as opposed to any proprietary hardware solutions, if you will. So this Dell EMC just basically boils down to three aspects that we focus on. One is open networking. So what is open networking? It's basically in contrast to traditional integrated network switches currently used by operators and enterprises, disaggregated switching, which is Dell EMC's vision, basically uses merchant silicon-based switching systems combined with either commercial or open source software. The second major pillar of our vision or architecture, if you will, is being software defined. So what this means is being able to harness open source and open ecosystem capabilities to advance networking industry, as we move to DevOps or NetOps models, being able to support cloud native platforms of cloud native applications. And the last kind of major focus at Dell EMC is to leverage the networking technologies that we've discussed so far to deliver market-leading converged and hyper-converged infrastructure solutions. So we looked at it, a lot of the discussion that I've had, just now was probably enterprise IT focus. So I want to shift the gears a little bit and talk about our operators or telecom customers, if you will, the large service providers around the world. Interestingly, their drivers for to modernize and to change are very similar to what we are seeing in the enterprise space as well. They'd like to build efficient, flexible platforms which can deliver services quickly. Agile platforms have an open ecosystem to be able to leverage third-party applications and innovations, and the path to hyperscale. So they want to be able to scale, especially in the mobile space, being able to deliver applications irrespective of what device that the customer may be connected to, and just in general being able to virtualize network functions, NFV, if you will, service and function agility. So what these are leading to is some of the concepts that we keep hearing from service providers is evolving the central office to the next generation, being able to leverage the Internet of Things and the applications that it brings, and MEC is basically mobile edge computing, is being able to deliver mobile applications, and in general, the next generation enterprise connectivity, if you will. So just yesterday, as a matter of fact, we recently announced a partnership with British Telecom to drive innovation using disaggregated networking solutions. So what BT were seeking, they were seeking the benefits of SDN and NFV, network function virtualization, and programmable silicon. This is kind of what their discussions with them said, okay, these are the three main goals that they'd like to see. And if you dive a little bit deeper into what they're looking to see, some of the examples that they told us is essentially instant activation of Ethernet circuits from third parties such as enterprises, and the ability of the system to be able to deliver real-time network operational data, so telemetry information to be able to deliver to third party. So what we're working with them is, this is essentially, we're working with BT, it's in their labs, they're going through a proof of concept, but basically the platform, one of the things that we are working with them and seeing and testing using our disaggregated solutions is to deliver services such as bandwidth calendaring, which basically means you want to be able to deliver flexible bandwidth on an Ethernet circuit based on certain time within the month. So basically scale up the bandwidth during certain times when there's a large demand for it, and then scale down. Essentially use the network, dial up and dial down bandwidth, but basically do it instantly. And also the ability to integrate with third parties and deliver telemetry data to them. So why open networking? So basically Dell's vision and why we support open networking is, you can kind of, I talked about this a little bit, but let me explain perhaps a little bit more. Essentially, we believe that open networking is a very disruptive technology. It has new architectural frameworks. It enables new ways of thinking of delivering services, and it has new go-to-market models as well. And basically, it builds an ecosystem, an open ecosystem, if you will, to deliver innovation faster to our customers. It also essentially restructures the CapEx, OpEx models in terms of how customers spend, and the customers will have the ability to deliver, the customers will have the ability to lay out or spend for services as they turn up customers, instead of, having a big, large investment initially and then, kind of amortizing it over a large period of time. They'll be able to spend as they go, if you will. It also resets a lot of the TCO models for our customers, and I think that's a good thing, and that essentially resonates with our customers a lot. And the last, and this is perhaps very important, is that it actually redefines R&D funding in the industry, and there's a lot of innovation models that happen basically through open source. So in terms of looking at it a little bit more, or to add more color to it, the open networking model that Dell EMC is supporting is basically, it's unlocking a lot of R&D investment through the use of open source. So at the hardware level, we support the ONIE, Open Network Install Environment, and the switch abstraction interface, which lets, networking OSs and other third-party vendors to be able to support, and we'll be hearing from one such vendor today, vExpert, who are a very close partner of Dell EMC. More importantly, this architecture also enables, for example, working with SDN controllers or any kind of network overlays, if you will, and also the standard orchestration and automation tools, and unlocking the R&D investment and unlocking the open source innovations that are available to third parties. So with that, I'd like to pass I'd like to invite my colleague Gary Greenberg to carry this discussion. Gary.
Thanks, Ram. So I'll be talking about some of the key software-defined data center requirements and providing an overview of some of the architectures. So first of all, the clear winning service delivery model in today's service provider market demands agility, modularity, and openness. This has been demonstrated for years by next-gen service providers and their ability to innovate by removing the hard link between service design and delivery, arguably two different skill sets. The old world is siloed, static, and slow. The new world is layered, agile, and rapid. Design and deployment flexibility has driven the modern data center to being software-defined, enabling services to be abstracted into high-level descriptions or models that are deployed in virtual compute and storage workloads on virtual networks overlaid onto physical network resources. The service models are created from libraries that are stitched together, instantiated, and lifecycle managed at demand time, rather than deploying physical elements for specific service or customer use. Virtual server, storage, and network resources are allocated, monitored, and adjusted according to service level policy. In order to achieve this abstraction and resource pooling, the physical network underlay must be dynamic, robust, and scalable, which implies programmable. Software drives service level costs and security assurances by monitoring the data center workloads with closed loop policy actions that make dynamic corrections. For example, when bandwidth thresholds are crossed, seek new paths. When CPU load thresholds are exceeded, move those workloads to less utilized server resources. Another important aspect of the modern software-defined data center is that it must be built on open network elements that enable service provider-tailored solutions rather than vendor-tailored solutions to provide service providers with the ability to differentiate and customize their solutions. Modularity through open system interfaces allows the service provider to maintain desirable investment economics and to dictate design goals without compromise. Ultimately, the virtual and physical layers must be presented on as a holistic system evolved from common operational methods in order to reduce, rather than replace, the operational complexity as promised by the technologies of the modern software-defined data center. Dell EMC open network fabrics create the agile, deterministic, and dynamic underlay networks that the modern software-defined data center demands. Common fabrics are based on a two-layer CLOS architecture using so-called leaf and spine switches that provide deterministic, non-blocking, any-to-any connectivity in one hop with fault tolerance. East-west traffic capacity is the most demanding in today's data centers. Network capacity scales out in these architectures by adding spine and leaf switches. The non-blocking performance has been shown to be achievable as the capacity of spines is equal to or greater than that of the leaves. Oversubscription is managed at the leaf layer. Compute and storage capacity is typically added on a rack unit basis while tenant virtual networks span these racks. Dell EMC switches support agility, and the underlay implies flexible packet forwarding design at the network layer. For example, layer 2 and 3 forwarding, protocol support that includes BGP, equal cost multipath, VXLAN, GRE, various layer 2 and 3 cost protocols, as well as OpenFlow and netconf yang for SDN designs. Dell EMC switches are also open OS capable. This means the OS of your choice, the ability to tweak that choice, as well as doing SDN control or not, and being able to choose your SDN paradigm. Open Network Install Environment, or ONI, is used to boot the Dell EMC bare metal switch configuration. Equal to the individual capabilities of vCenter, NSX, Big Cloud Fabric, and Open ON solutions is that their virtual and physical layers must be presented as a holistic system, and they are. There's no room for back and forth between physical and virtual provisioning and troubleshooting and analytics and security platforms. APIs and partner collaboration enable this single holistic platform. Think of flow-through functionality by passing data, objects, and commands between the platforms. vCenter and Big Switch networks enable partner platform extension, thereby allowing the coordination that in the model with NSX allows Big Switch networks products to augment the physical layer network control, while NSX controls the virtual layer. For instance, Big Cloud Fabric extends support for VMware NSX network virtualization by providing complete NSX virtual machine and host visibility in the BCF controller, BCF Analytics extended for VMware NSX connected virtual machines, rapid VTEP to VTEP troubleshooting and BCF underlay across the fabric, including source VTEP, source leaf, spine, destination leaf, and destination VTEP. Specific capabilities of the Big Cloud Fabric vCenter integration include auto ESXi host detection and discovery and lag formation, auto layer 2 network creation and VM learning, network policy migration for vMotion DRS events, as well as other unified capabilities. The vCenter NSX BCF ON solution represents the power of openness by bringing best-of-breed products and capabilities into a single solution platform.
Now we want to actually make it a little bit more interactive and get some feedback from attendees. So what we'd love you to do is make a selection in the quick poll box that should be showing up in your browser now. As you do that, we'll be able to tabulate some of those results and see what's the top pain point across the audience at this point. And as we wait for that to happen, we are going to be going deeper now into the Big Cloud Fabric and Big Switch stack and how that integrates into multiple VMware workloads. And should be quite interesting to show you how we do networking at the speed of virtualization, really allowing a seamless ability to provision a VM, provision software-defined storage, and then push that live into your network in one workflow directly from vCenter, which I think you'll find quite interesting. All right, so let's tabulate the results here, and it looks like automation across domains is definitely up there, along with troubleshooting in the lead, followed by service agility. I'll hand it over to my colleague Prashant.
Perfect. Thank you, Greg. The wind of change in the data center is blowing hard, and it's as a team has discussed here, really the software-defined data center innovation in the data center is accelerating, and it's really driven by these cloud-native applications that require very agile, very speedy, highly visible infrastructure, whether it's across compute, network, and storage. And so with this transformation that customers are demanding, if we look at, if we want to purchase real estate, the three key top care abouts are location, location, location. And so when we talk to customers regarding software-defined data center, their three care abouts are really speed, speed, speed. And that speed of deployment, speed of change management, speed of provisioning of applications and virtual machines and containers, its speed of upgrade of software, and its speed at which they are able to rapidly troubleshoot connectivity issues and other issues that come about in the data center from operations perspective. So speed becomes a top of mind. I was talking to one customer and he said, Prashant, software-defined data center for us means speed-driven data center. How do we bring that level of speed? And as Greg pointed out, how do we make the infrastructure, and network being one of the major bottlenecks in provisioning this infrastructure for speed, we'd like to have our VMs and containers be deployed at the speed at which we instantiate them, which is within seconds or less than a minute. But the network being that bottleneck, does not allow us to get that speed. So the whole purpose that vSwitch has is to make this network transparent, invisible, by adding software, by bringing innovative capabilities and workflows that are human-centric and drive the machine details under the hood. And we'll see how we do that. But just coming back to our traditional network, very box by box, a 25-year-old architecture that is brittle, that has to be provisioned for every protocol and every node knob on every switch using a very old configuration model called the CLI. And the interdependencies between these switches and boxes is so complicated and so convoluted that it is super hard to troubleshoot and breaks all the time. So how do we go away from this old environment and really bring next generation feel, the modernization feel that hyperscalers have brought? Google, Microsoft, Facebook, they are building large infrastructures, very large networks. They're leveraging software, they're leveraging open networking hardware to be able to bring tremendous innovation in networking that we are not able to see in a traditional vendor environment serving our enterprise and service provider customers. And so if we kind of fundamentally look at this and look at it from an angle where we can really understand how change can be brought to networking. And so the example that we felt was very relevant to this was our driving experience. If the automobile were to expose the engine is a highly sophisticated machine, lots of node knobs, lots of features. If all of that is exposed to the driver, then you would have this very complicated cockpit in front of you, and it would be a challenge to drive the car, and certainly only a very small subset of the population would be able to drive the car and would have to be certified. But the car industry got it right from very beginning, because the car is meant for humans to drive, so humans think in terms of their intent. Their intent is to drive forward or reverse or brake or accelerate or steer, and those are the workflows that are exposed to the driver. And the rest of the complexity of carburetor and spark plugs and timing belts, all of that is kept under the hood, away from the driver. And hence, we have a 16-year-old who is able to drive the car, a highly sophisticated and complicated machine. And this baseline of intent-driven driving has been fundamental to the industry now going to self-driving cars and autonomous driving. So in networking, what we have done, unfortunately, for the last 25 years is we have brought the engine to the user. We have exposed all the features to the users, and that's why it has been so complicated, and it has been so brittle and so hard to troubleshoot and highly proprietary. What vSwitch is really focused on is a very structured topology, a cloth network for data center switching environments, for modern workloads as well as traditional workloads, to bring that flavor of intent-based operational environment. And what do we mean by that? By representing the entire fabric as a single logical switch or a redundant, highly available logical switch, we are able to show intent from the perspective of the operator. I would like to add a VM. Network should be automatically configured. I'd like to add a switch. Network should be Fabric should be automatically configured. I want to add a server. It should automatically be recognized and provisioned. Top of rack switch should be provisioned and admitted to the Fabric. So these workflows, very human-centric workflows, allow us to bring speed and integration into orchestration system, so that while there is tremendous sophistication in this programmable software-driven Fabric environment, it becomes invisible to the operator, in the sense that all of the change management can occur in a hands-off manner. And that, we believe, allows us, that's the right baseline to enter into the next evolution of this of networks, which is autonomous networks, or diagnostic self-driving infrastructure for networking. So we believe this is what we mean by next generation. Traditional networking vendors have typically talked about new networks, and what it all is that they're trying to bring some of these new concepts, such as intent-based networking, but in an old wine bottle. So it's that makes it essentially a bolt-on solution on an old architecture, and that's just we see that as a poor man's way to advance networking. What we need is truly a software-defined networking that is intent-based, and this is what Dell and Big Switch are bringing to the table. And we'll see how this intent is integrated through VMware products, vSphere, NSX, vSAN, to be able to make the network operate at the speed of the VMs. Now let's look at some of the workflows that are intent-centric, what network operators would want to do. So a very simple one is changing a switch, adding a leaf or a spine switch. That's a one-click operation with Big Cloud Fabric. Forming a class topology, as earlier was mentioned, you have leaf and spine, and there are interconnections, and every time there's a link change or a switch change, you need to reform the fabric. Well, in the case of Big Switch, it is zero touch. Once the switch comes up, links are connected, the fabric is automatically formed. There is no manual configuration required. Suppose you want to add a server, like an ESXi host. It's automatically configured. The top of rack switch is automatically configured with lag. There is no manual network intervention required, which means that the virtualization team can keep adding ESX servers with NSX, vSAN, add clusters. All the change management can occur without having the network be the bottleneck. Upgrading the fabric. One of the things with Big Cloud Fabric is we bring rapid innovations, new features very, very quickly. And we would like our customers to adopt these features very quickly. And one of the challenges in networking is that upgrades take hours and hours and hours, multiple maintenance windows over multiple weekends. And that's why many customers don't like to upgrade once they're on a stable release. Well, in our case, most of our customers are on on our N-1 release. So if we're releasing 4.2, many of our customers have already been on 4.1. And the reason for that is the entire fabric upgrade is a three-step upgrade, and it's done in less than a coffee break. And so that level of speed of upgrade becomes super critical for customers to consume innovations. Multicast, one click, creating networks. It's really automated. VMs are created, and the network is automatically created. Visibility, tracing across the fabric. It's just one-click operation, and we'll see some of these workflows sort of in real time as part of the video demo. So let's kind of look at now the use case of VMware workloads that are instantiated on the Big Cloud Fabric, the Big Switch SDN software for leaf-spine fabric, and leveraging Dell Open Networking switches. The integration of Big Cloud Fabric is through its SDN controller into the VMware environment, and through the Big Cloud Fabric's plugin for VMware, one is able to, or we are able to bring full fabric automation for VMware workloads, complete automation to ESXi host as they connect to the network, full visibility from ESXi source to destination or source VM to destination VM across to ESXi host, and complete troubleshooting and analytics. And this is across the entire family of products, whether it's vSphere, NSX, hyperconverged solution using vSAN, the virtual desktop solution with Horizon, as well as VMware's solution for OpenStack and containers. And in addition to providing the sophisticated capabilities on the network side, we also enable the virtualization team to have visibility to the fabric from the comfort of their own management console, particularly the vCenter GUI client. So with our plugin, you can see the entire big cloud fabric operations through that, and we will see a demonstration of that. We've also integrated in vRealize Log Insight so that one can get a very consistent and centralized log and events capture through vRealize Log Insight. So drilling down a little further, what are some of the requirements for these three key components of VMware SDDC? For vSphere, VMs are created. How do we create the network at that speed? How do I troubleshoot VMs, VM to VM connectivity? For NSX, it's really an overlay underlay architecture. And the key care about is, what about the underlay visibility? How do I troubleshoot? How do I know what kind of traffic is being transported on the overlay? And that's become a major customer care about. And finally, storage. How do I add vSAN nodes that are automatically recognized? vSAN transport network is automatically formed, and I get nodes and cluster visibility right in the network environment. So the whole idea is to make the network very virtualization friendly, provide virtualization context and visibility in the network, and also operate at the speed of virtualization. And that's what Big Cloud Fabric does. It is, a leaf-spine fabric. Big Switch is essentially the SDN software that resides on the switches, as well as on the controller. Switches are Dell open networking switches, and the entire solution can be procured from Dell. And so combination of integration into VMware, leveraging open networking switches from Dell EMC, and the Big Switch Big Cloud Fabric software enables, brings tremendous speed, and we'll see some of the customer examples. It brings down CapEx significantly, significant advantage in operational speed as well as operational cost, and provides tremendous visibility. And we'll see all of this in detail over the next few slides. So let's start with vSphere deployments. What Big Switch has done is to, through a vCenter plugin, we are integrating with the VMware APIs, and we have also placed a Big Cloud Fabric plugin right into the vSphere web client so that the fabric visibility is available to the VMware admin. So with this capability, hosts can be automatically detected, ESXi host, and the fabric is automatically configured for interfaces such as link aggregation or MLAG. The L2 network is automatically created when VMs are deployed and port groups are created on vCenter. And whenever vMotion or DRS occurs, the network policy is automatically migrated to the new ESXi host. It's tremendous visibility, VM level visibility in terms of the context of the VM, VM name, vMotion events, which hypervisor it belongs to, which ESXi host it is residing on. All of this information is available to the network admin, and vice versa, the fabric information is available to the VMware admin. Entire VM to VM troubleshooting is available to both the admins, and so our approach is to provide a very consistent environment, to the virtualization admin, the fabric visibility environment, to the fabric admin, the virtualization environment. So when troubleshooting events occur, both are looking at a very consistent environment, and that we believe helps, and our customers have seen in real time that it really helps troubleshoot issues rapidly. Here's an example of how one would run a trace across the fabric. One would select in the Big Cloud Fabric's SDN controller a source VM and a destination VM, and simply press a button to get the entire path that allows the user to go from source host to the specific Ethernet port on the rack 1 leaf 1 switch, traffic traversing to spine 1 switch on specific Ethernet ports, then to the destination leaf switch and to the destination host. And so this entire path is available at a click of a button to the network admin from ESXi source host to ESXi destination host. And interestingly, the same information is also available to the VI admin. For example, and we'll see this in the demonstration as well, the ESXi host, how its VMNICs are connected to the upstream leaf switches or top of rack switches in a rack, including the link health information and the specific switch names associated with these links, and the Ethernet ports to which the links are connected on the top of rack switches. And similarly, the VI admin can also run fabric trace right from vCenter BCF plugin, so that they can see how the traffic would flow on the fabric and whether or not the fabric is responsible for connectivity issues, or are there misconfigurations in the vSphere environment or ESXi host that is creating the problem. So this ability to rapidly identify whether it's a network issue or the server issue or virtualization issue makes resolving issues very, very fast. And finally, full analytics built into the product, including dashboards for all of the VMware SDDC assets, including vSphere, NSX, and vSAN. So one can do historical analysis, look at all the events and logs, and be able to understand what happened at 2 in the morning, and such scenarios can be easily addressed. And finally, before we go to the demo, a quick note on NSX. NSX is essentially SDN for the virtualization environment. It provides network virtualization. So SDN for the vSwitches. What Big Cloud Fabric provides is an SDN for the underlay. It's the SDN for the physical switches. And so we believe an SDN overlay, in other words, NSX, is best run on an SDN underlay. And that's really Big Cloud Fabric, which presents the network as a highly available logical switch to NSX, which presents, brings workloads on its own logical network for network virtualization. And all of the benefits that we talked about are extended in the NSX environment, including support for hardware VTAP that we have been demonstrating. Analytics for NSX are also provided. So now an underlay operator has full visibility to the overlay traffic, including NSX logical switch, the VXLAN ID, the VM name associated with the logical switch. This information is available. It's historically captured, so one can replay in time and see, what events have transpired, last week or yesterday. And finally, how are the customers adopting this infrastructure? And so I have 3 examples, one for vSphere, NSX, and vSAN. So very large Fortune 500 manufacturing company, has deployed Dell networking across multiple data centers with Big Cloud Fabric solution for addressing their vSphere workload environments. And these are 70 to 100 switches per data center. They have been able to bring the environment up very, very rapidly. Similarly, a large insurance company, these are mainstream enterprises, and a mid-market regional credit union that has deployed vSAN. An insurance company, of course, deploying the NSX solution. So significant benefits that they have seen in terms of OpEx and CapEx by deploying this stack. So with that, we'll jump into a quick demo. So we are going to show the ability of BitCloud Fabric to be integrated with VMware, and how a VI admin can have the visibility to the fabric and some of the provisioning and troubleshooting workflows. So this is regarding vSphere, and the first portion is going to really talk about how we provision for the plugin, and then we will see some of the workflows within the plugin. So deploying the plugin is very easy. It's done in the BitCloud Fabric controller. It's a very quick GUI-driven workflow to deploy the vCenter plugin. And once that occurs, one would associate the controller with the vCenter, and that vCenter provisioning is also very easy through a GUI screen. So once that occurs, the BitCloud Fabric controller shows the association with the plugin, and the plugin also shows up in the vSphere web client. Once we are in the plugin, it shows all of the BCS fabrics. Here is one of the fabrics, pod 103, and it shows that it is associated with 2 vCenters. We can have multiple vCenters associated with the pod, so that's not an issue. And in this case, there are 2 vCenters that are associated. If we go to tenants, it shows all the tenants associated with that pod, including those associated with the vSphere workloads. If we go into one of the tenants, all of the segments, specifically L2 segments like VLANs, are shown, and association with ESXi hosts and associations with the VMs is provided. One can also configure gateway addresses here if the authorization is provided by the network admin. You can go into a particular segment and see all the workloads associated with that, and this is all done within the vSphere environment. You can search for Ubuntu VM, and when you don't have to search through IP addresses and MAC addresses. You can leverage standard names of the VMs to be able to do that, and also look at how an ESX host is connected to the upstream top-of-rack switches. It's very easy right in the comfort of the vCenter. Now, let's figure out whether or not 2 VMs can interact with each other. Again, this is done directly from the vCenter GUI. There's a test path capability that is built into the plugin, and one can even do test path across VM kernels if it's a vSAN environment, as was identified here. Now, we'll pick a VM, 31.1 something, which is a CentOS VM, and so you can search through IP addresses, of course, but you can also search a VM through a VM name, the Ubuntu VM, and we'll pick that, and we'll see these are 2 different VMs on 2 different hosts across 2 different racks, and we will see what the connectivity diagram looks like. It's right here, and now we are going to actually send the traffic to see how the traffic flows across the various ports on the fabric. And here, what we are showing is that once the test runs, one can see that the traffic goes through exact Ethernet ports on the exact leaf and spine switches, and so one is able to troubleshoot very quickly to see if it's a network issue or a fabric issue.
So in this demo, I'll take time to talk about the advantages of deploying BitCloud Fabric as VMware NSX underlay. As a part of this demo, I'll also show the technical preview of our hardware VTEP functionality on VMware NSX. We'll see how NSX node connectivity and transport network are automated. They are provisioned in the underlay. We will review NSX hardware VTEP setup for big cloud fabric and understand the advantages of monitoring this entire network, troubleshooting options, as well as all the necessary fabric analytics related details. So let's start with the topology, what the setup is. On the left hand, we have a logical topology with NSX controller and vCenter connecting to big cloud fabric controller, which is a single point of integration. NSX transport network has 3 NSX software VTEP and 1 big cloud fabric hardware VTEP. Logical network in green color corresponds to NSX overlay with VMs behind different NSX VTEP nodes, as well as bare metal host behind big cloud fabric hardware VTEP. On the right hand side, we will show that physical topology with a big cloud fabric. And here I'm showing a spine leaf architecture. The setup I have has 2 spines and 4 leaves. We have 3 physical hosts connected for ESXi virtual workloads and 1 bare metal host. We have deployed integration with vCenter, and let's look into how this looks like. So here on vCenter console, we have 3 ESXi hosts. We are showing all the necessary information related to host configuration, your VM kernel interface IP, and the segments. So as mentioned earlier, as soon as this integration is set up, we will start talking to these hosts. We'll have all the links up by our integration. We'll detect all of these things. And this is where I'm showing on big cloud fabric console all the ESXi that are learned, the 3 ESXi hosts that are learned here. You can see these port groups are up, interface groups are up. They are using LLDP protocol, as I'm showing on the right hand side. If I go into more detail, I can see what physical port and where they are connected to. In this example, I have leaf 0B with Ethernet 25. It's connected to ESXi host, VMNIC 2. And similarly on VMNIC 3 for second switch. Once I go into a particular segment for that particular tenant, I can see all the detailed membership information, group membership information. Here I'm showing all the endpoints that are learned through this, this integration. And all the VMs, they are also learned as an endpoint. These are sitting behind this host. Let's look at the basic configuration that we have for VXLAN termination. Here I'm showing all the necessary information for VXLAN. It's very simple setup that all you need is define a VTEP and define a particular IP address and you are set. You don't need any fancy configuration. You can also see that remote VXLAN tunnel endpoints are not populated here. And the main reason is we have not enabled the OVSDB on NSX to start this communication. So this is like a very basic setup that we are just starting. So let's go to vCenter. Before I go there, here I'm showing that I'm able to ping between 2 VMs. And if I try to ping between VM and bare metal, I'm not able to reach. So let's enable vCenter. On vCenter, let's enable this NSX OVSDB integration so that this communication with the VM and bare metal starts taking place. All right, here I have already configured, I have got the information related to certificates. So all I need is define a name and insert the certificate information. Once I do this, because of the configuration point with the OVSDB and my integration, I'll start learning the information for this particular, let's take an example of this logical switch. with 10,000 switch ID. What I'm doing here is I'm adding a bare metal into this particular segment and enabling a VLAN. In a way, I'm mapping 10,000 VNI ID with a VLAN 25. As soon as I do that, you can see that I am able to ping between bare metal and VMs. All right, so now as we can see that this remote tunnel endpoint that was not populated earlier is now populated. So communication from NSX controller to Big Cloud Fabric controller is happening. If you see in the bottom of the screen, I am showing all the remote endpoints as well. These are again dynamically learned. Let's look at a test path. Earlier we did test path using Big Cloud Fabric plugin for vCenter. Here we will do test path directly on the Big Cloud Fabric controller. A very similar concept, you pick a particular source that you want to check communication and a particular destination, and then you enable simulate. Very similar to what I've shown in plugin. Simulate is an option. It's more of a controller view that controller shows from controller logic per se how this communication should go through. So in this case, it's very simple. You have a source and a destination talking to VXLAN endpoint, that is VTEP. However, if you look at the physical part of this particular communication, you will see that this is happening between an endpoint and a VTEP, going through rack 1, spine, and rack 0 all the way to VTEP. I can also do actual test with traffic, and here I am showing on the right hand side this test with the traffic indicates the traffic flows from Ethernet 23 to leaf 1A to Ethernet 51 connected to Ethernet 3, goes to spine 0, so on and so forth. And then on the rightmost side, I'm showing all the packet TCAM counter that are going through this particular flow. Switching to Big Cloud Fabric, Fabric Analytics module. On the left-hand side, you see all the dashboards that we have created for VMware and other use cases. Let's click at all events. Here, I can go down and see all the necessary events that have taken place. I can click, I can drag specific time on the top window, or I can go into specific vCenter. Let's click on a specific vCenter and a hypervisor here. And once you select, all the necessary events will automatically be filtered at the bottom of the screen. All right, let's look at NSX particular, NSX specific detail. Here I'm showing this particular NSX with a logical switch and a VM name. Once I select a particular VM, I can go down to see specific information related to that particular VM. A vCenter, a logical vSwitch, VNI mapping. Remember we used 10,000 and VLAN 25. All of that information is shown on the analytics module. This helps troubleshoot all of this connectivity in the underlay, which was basically trouble for any overlay type of deployment. So a quick recap on this particular presentation. We have seen that by deploying Big Cloud Fabric for NSX underlay provides you benefit in terms of visibility and automation for NSX deployment.
We also actually have, let's see, as next steps, the ability to go on and experience firsthand the Big Switch Labs environment. We have 12 hosted lab demo environments. They're each instances of Revela that spin up for your use, self-paced labs. We've had over 5,000 people actually fire these up and take a look at what next generation networking really looks like. One of the things you'll really find that's markedly different from the CLI-based approach to managing traditional switch-by-switch networks is this very intuitive UI and built-in analytics with dashboards that are drillable, very intuitive, even for non-CCIE type folks. So I encourage you to go to labs.bigswitch.com. You can get immediate access. There's demo modules for integration with VMware, as well as OpenStack, as well as a new module that will be launching shortly on container networking, which we're all quite excited about. And finally, there are also additional information that you can get by going to bigswitch.com and check out the Dell partner page to learn more information about our joint solutions. We'll be at VMworld in about a week and a half, and please come and visit us at booth 808 for Big Switch and booth 400 for Dell EMC. We'll have demos, live demos, and SEs to be able to go deeper. So with that, we'll go ahead and wrap up the session. Thank you very much for your time.